Hi guys, Buildzoid here, and today we're going to be doing something I haven't done in quite a while, which is take apart a GPU on camera. I do take apart GPUs quite regularly, but not very often on camera. So yeah, this right here is an XFX RX 9070 Swift OC. I bought it. This is not a review sample. So a big thank you to the channel supporters for making the purchase of this card possible. So yeah. And if you'd like to support the channel, there are links in the description that you could check out. That would be very much appreciated. And with that out of the way, let's get into it. Yeah, 3-fan card, has a backplate. The backplate is metal. The actual shroud itself is plastic, which I think is perfectly acceptable because, let's be honest, this doesn't serve much in the way of functional purpose. I do appreciate the fact that actually XFX, I'm not sure how visible this is, but the heatsink has this like metal support bracket that like bolts into the actual PCIe slot. I do like PCIe bracket, which I do appreciate because there are some very big, heavy cards that sometimes they'll even have like a giant PCIe bracket, and then there's nothing that actually like screws into it. So yeah, so that's nice that they're considering the rigidity of the card, and I guess that's also part of why. Actually, no, this just kind of bends up and doesn't really connect to anything. Yeah, I mean the heatsink screws into the shroud back here, but yeah, this part is purely aesthetic purposes as far as I can tell. Yeah. Doesn't actually structurally attach to anything. So anyway, let's get into it. We'll start off with the screws on the back, I think, because yeah. I mean, obviously we also need to undo the ones over here because actually I think the backplate's going to come off and there's our warranty sticker. That's going bye-bye. I mean, I wasn't expecting that warranty sticker to last very long because yeah, if I didn't want to do questionable things to the PCB of this card, I wouldn't have to buy it, would I? So, let's see. But yeah, there's a warranty sticker. And I would kind of like to... I guess we'll just go through it with the screwdriver. It's just like I didn't want to embed warranty sticker into the head of the screw. Also, the first bit that I chose was too big. This one's the right size. Whoa, okay. It's very small. And also really long. Yeah, that is like a surprisingly long screw. I'm kind of hoping that they'll at least use the same ones everywhere if they're this long. Like, being extra careful. I don't want to strip the heads. Like, as much as possible. So. Yep. And there goes my warranty. I mean, I think the sticker like is more, well, depending on what region you're in, that sticker might function more as an anti-tamper check rather than actually like fully voiding your warranty. But in my case, once I get the soldering iron to the board, I don't think that's when it'll for real be no more warranty. Okay, so that's the back plate out of the way. I did not consider where I would put it. Okay, there we go. Oh, so we have the regular spring bracket, which I am not a fan of. Like, the reasoning behind why this is used makes perfect sense. I don't like the leaf springs at all. Like, these are just super annoying to deal with. I think at this point I'll undo the screws on the I/O, because otherwise I don't really want to be dangling the entire heatsink off of the I/O bracket. So, oh, and that uses different heads. Lovely. Well, at least the thread size is also different, so it's not like you'll mix these up during your disassembly, because it will, like, these will not go into the backplate holes. They're too big for that. Okay, and time to deal with the leaf spring. My least favorite part of this assembly. Hopefully it doesn't, like, jump up too much. Oh boy. And it's tight. Yep. Well, that's expected. Oh boy. I think this bit is yeah, it looks fine. This one might work better. Technically, these are the same size, but like I have a whole bunch of bits that are like the same size, and there's like slight tolerance differences, so some of them fit a bit more snug. Okay, that didn't pop up. Yeah, this one works better for this. Oh. At least the screws for these are captive. There are actually some GPU manufacturers who have leaf springs with non-captive screws. That's like mainly, I think, a pallet thing, and it's infuriating because if you don't like make sure that the bracket doesn't pop up, like it can actually like launch the screw into space. So yeah, not fun. Is that everything? Because I don't want to start reefing on the PCB. If there's still something holding it together, because that would obviously not be good for the PCB. But I'm pretty sure that at this point it is only attached with thermal pad and thermal paste. Oh, these are soft. Okay, this is letting go. Nice. Okay, nice and easy. Ooh, so this does have the PTM 7950. Yep, that's definitely PTM 7950. I kind of wonder if I'm going to have to replace it. Oh well. Just gonna use a flat head to deal with the fan header. Oh. Oh, I guess, nope. Like, I want to give you guys an angle, but then I can't see, so... Okay, this actually works. Get it in there. And pop it off. That way, like, you really... Well, I mean, sometimes you can get away with just pulling on the cables, but if you, like, if you get unlucky, you can rip the, like, terminals out and... Or rip the wire out of the terminals, and that really sucks. So, anyway, here we have card. Yeah. It's not a very big PCB. And one of the main reasons I bought this thing is because it looks like AMD has started using shunt resistors for enforcing the power limit, and I find that very interesting. So, yeah, we got a shunt resistor here, and a shunt resistor there, and another one for the PCIe slot. So, yeah. I don't know what they're connected to, and we're not going to find that out right now. The thing I want to find out right now is just like phase assignments and resistances is what I'm wondering about. So here we go. Got the multimeter. Gonna put it into resistance mode. And man, we've got a lot of voltage regulators on here. Yeah, we got like, that's a voltage regulator, that's another one, that's another one. That's probably 5 volts over there, because, wait, is there anything on the other side? No, well, not really anything. Oh, we have like a linear regulator over here. So, yeah, this thing's packed. This kind of, like, the form factor reminds me of the Fury X PCB. That's, like, roughly this size, and also has the 2 8-pins. Completely different, like, actual layout, but vaguely the same sort of, like, small PCB, lots of power, like, big power connectors kind of setup. So anyway, the thing is, I don't know what these two are. And they're going to be different voltage rails. This is going to be another voltage rail. Also, my probes are all tangled because of course they are. I like, if somebody made anti-tangle probes, I would buy them. Anyway, okay, we'll just grab ground off of one of the display ports and start poking things. So that's 260. Also, if you're wondering why I'm doing this, this is just for, like, if you ever have a broken card and you want to repair it, knowing what all of your resistances are supposed to be from a working card, very helpful. That way you can tell if, like, some voltage, like, if some power rail is abnormal or not. So, yeah, so this one, 260, 1.2K. I think the main core power rails are going to be extremely low resistance. Yeah, so this is like a core power rail. I don't know which one yet, though. Huh, okay, so these two are probably the same thing. Yep, those are together. And this is something else. That's probably V-core, because that looks like a dead short circuit. So most modern silicon, the chip itself has very low resistance, even when the card is turned off. So I think this is probably V-core, because, yeah, that's 0.2 ohms. And if I measure from ground to ground, so I'm just going to grab a ground off of this capacitor over here, you can see that's 0.06. So yeah, this has like 0.15 or something like that resistance. That's the same thing. Same thing. You know, I gotta say, this PCB is very clean, considering that, like, I'm not having any contact resistance issues. Yeah, so these... Yeah. Yeah, so these 4 phases, I mean, I'm not even sure that these are necessarily separate phases, but these 4 are together. Those are in parallel. This should be memory power, and I'm guessing... Yep. And the resistance for memory is 90 ohms. That is surprisingly high. I would, like... Sometimes you get memory chips that are like 40, 45, like... Well, I think the lowest I've ever seen is like 15 ohm memory power rails, but this is 90, which is like... Like, that's like GTX 680 type stuff. In terms of memory resistance, but yeah, this doesn't really mean anything. It doesn't even tell you how much power the memory is going to pull, so just like a random coincidence that, like a random thing I noticed is that, yeah, that resistance is weirdly high, like, kind of high for a modern GPU. So that looks like it's all hooked up to these guys as well. Yep. So this are all together. Yep. And this down here, not. And this also, this is very different. This looks like it might be connected to these two. Because that was like also, what is it, 2.7? Yeah, 2.7. Yeah, it is connected. Interesting. So we have like three... I'm going to go that's actually probably a three-phase. Yeah, so that's probably like three phases together across like the entire board, which is kind of fun. Then we have one phase that's its own thing. Completely separate from everything else. And then we have the 8 up top as the main core power rail. That's a weird layout, though. I would have thought, like, the core power rail would have been, like, down here so that they could sneak the power plane, like, around the memory chips instead of under the memory chips. But yeah. I guess if you have enough PCB layers, it doesn't really matter where you're putting your core power rail. Just want to make sure. Yeah, these four really are like they're all just together in one group. Neat. I'm just looking at like the board to see if there's any. No, it makes sense. Oh, I guess, yeah, this is unpopulated. Right, so that would have been tied into that. Okay, makes sense. Makes sense. So, what I mean by that is like this right here connected to this right here. And it is. So that's cool. Then we've got this little voltage regulator down here, which I don't know what it's for, but the resistance is 28 ohms. So, yeah. Kind of wild amount of voltage regulators, actually, because we also have this thing. Oh, I didn't measure that thing. Expect kilo ohms. Yeah, many, many kilo ohms. That really looks like a 5-volt rail of some kind. Yeah, so that's going to be some kind of 5-volt rail, I think. And like basically on this GPU, what I would expect, like you're going to have core, memory, probably memory controller. I don't know. There should be a 1.8 volt rail somewhere. Yeah, I think I'll have to like check the Asus TUF PCB because that one actually has all the voltages labeled on it, and then I'll try like figure out how that correlates to this PCB. Now I don't have a TUF card, I only have this card, but there is like PCB pictures from Tech Power Up of the TUF, so hopefully the layout isn't so different that it's like completely different in terms of where stuff is. Because one thing I could have checked is the resistance of the 12 volts. But yeah, that's not... Like, the thing is, if your card isn't broken, the 12-volt rails should have, like, kilo ohms, if not mega ohms on there. So, yeah, that's pretty standard. And then kilo ohms on the... No, mega ohms on the PCIe. So, yeah, that's pretty normal. Nothing all that interesting there. So, the thing... You know what? We are actually going to try check the shunt resistors, because that's the thing I've been wondering about the most with these cards is, like, what are those shunt resistors even connected to? Because on NVIDIA GPUs, you have a few very obvious shunt monitoring chips on the boards. Oh, how convenient. We have an I2C hookup right there. Thank you, XFX. That's going to make certain modifications way easier. Like, they even labeled the ground, data, and clock. So, yep, that's cool. Thing is, I'm not sure if the shunt monitoring chips are on the back or the front. You know what? I'm actually not going to do that on camera. So, yeah, anyway, that's it for this disassembly of the card. I'm gonna try make a more, like, detailed PCB breakdown, later. But, yeah, maybe after I have some, like, measurements of the card actually operating and, some modifications on there. Actually, before the well, I need photos before modifications, but yeah. So, hopefully you found this video somewhat interesting, if not particularly useful, and that's it. So, big thank you for watching. If you'd like to support the channel, there are links in the description. If you'd check them out, that would be very much appreciated, and that's it for the video. So, thanks for watching, and goodbye.